Hello everyone, today we're going to be making one of these. This is a ball handle. I need this for a project that's coming up. As you can see, we have the ball at this end. It goes down to a plain shaft, flared base, and there's a boss at the bottom for fitting into what it needs to fit into. Now this handle is made using, ta-da! This is a Hemingway spherical turning tool. Now I bought this as a kit a few years ago. This was before I started my YouTube channel, which is a bit of a shame because this would have made a good video. Anyway, setting this up in the lathe and making the ball handles is what this video is all about. So we best get on with it. In the collet is a length of aluminium bar. It's 25mm, that's an inch in diameter. This bar will be machined into the ball handle. Our ball handle requires a female M8 thread machined into its base, and that's what we're starting here with the centre drill. Next, we drill a 6.8mm hole. That's the tapping drill size for an M8 thread. With cutting fluid in the hole we've just drilled, I place my spring-loaded centre in the tailstock and tap the hole M8. I clear the hole of swarf with a blast from the air gun. The face we're machining here will become the base of the ball handle. This base requires a boss in its centre. The boss needs to be 11.8mm in diameter and 5mm proud of the surface. With the boss machined to the correct diameter, I use a compound slide to measure in 5mm and then face the end, which will be the underside of the knob. Now a quick touch with the file to chamfer the edges. I bring the 25mm bar out of the collet a little and then part off 41mm from the outside face of the boss. The blank for our ball-ended handle is now complete. I have now placed in the collet a length of 25mm, that's an inch, diameter steel bar. In the centre of this bar I've just drilled a 6.8mm diameter hole. This bar is going to become our mandrel. Because the aluminium blank has a boss machined on its end, 11.8mm in diameter and 5mm deep, the mandrel must be shaped to accept that boss. First, we drill a hole 11.8mm in diameter and 7mm deep. Next, we ream the hole 12mm in diameter. Deburr the hole with a Swiss file. I use the air gun to blow out the hole, then check that the boss on the aluminium blank fits the hole at the end of the mandrel. It does. I squeeze tapping fluid into the hole and then tap that hole M8. Using the air gun again, I blast out swarf from that tapped hole. The handle blank needs to screw onto an M8 thread. I saw off the length of M8 studding, deburr the ends of that studding, then file them flat. I install the studding into the mandrel, lock two nuts together so the studding can be tightened, and then I remove the lock nuts. Cut the studding to length, then deburr its end. The mandrel is finished. Now let's see if the blank will screw nicely in place. It's got to go onto the thread, and that surface there of the mandrel has got to go against this surface of the blank, and the boss on the end of the blank has got to go inside the aperture in there on the end of the mandrel. So let's screw it on, and hopefully those two surfaces will come together. They're getting close and they're meeting just there. So we've got a good fit between the boss and the mandrel. This is my spherical turning tool. I built this from a kit. The kit came from a company called Hemingway. They're based here in the UK, but they sell their kits all over the world. I modified this kit slightly. I put a larger piece of metal on here to go into the tool post of the lathe, and I also extended the bar here to the handle. It works quite well. The first ball that I ever turned is actually here on the handle. Now let's go across to the lathe and we'll fit this block in the tool post. It's now time to set up the spherical turning tool. Now this is quite easy. Since I put the job on the mandrel, I've faced this edge, so the turning marks on there show me where the centre of the job is, and I can see that quite clearly. Now the tool itself here, there is the forward edge is where the cutting is going to take place. That cutting edge needs to be in line with the centre of the job in this axis, and you adjust that by moving the cross slide backwards and forwards. So come up to the job, then we move it backwards and forwards until we can see that the forward edge of the cutting tool is in line. Once it's in line, you then put the lock on, and that will stop you moving in this direction. Right, the next axis is up and down. Now we do that by altering the position of the tool, so the tool height is what we're looking at here. Now again, the cutting edge on this tool is on the top surface just here, so you bring it in and you eye it up so it's just touching this side of the job. You then turn the tool over and you look at the gap here. And then you keep adjusting the tool height until the gap that you have between the tool and the job is the same distance at the top to what it is at the bottom. Now the tool is set up. I'm about to turn the lathe on and start our cutting. Now you've got to remember that the job revolves anti-clockwise looking from this end, so it will only, the tool here will only cut at the top there, and also as it goes over the top of the arc and cuts on this side. It won't do any cutting at the bottom, even though the tool falls down that way. Now there is another adjustment on this tool, and it's this screw just here. What this screw does is move that tool closer or further away to the center of rotation. So what that means is this slide here will adjust the diameter that the tool is going to cut. Something else which is very important is when you bring the tool to the top of the job like this, you mustn't go over center, because if you go over center then the tool will start to dig back down again, and we don't want to start going down again until the tool has actually touched the end of the job here. Because if we go before it touches the end of the job, that means that this side of the ball is going to be too far in that direction and we won't make a ball. So let's turn the motor on and start our cutting. Now what I'm doing is, you can see it's cutting just at the top, and then I'm going to move the tool closer to the job using the compound slide, and then bring up the tool again until the 90 degrees and back, and I'll just keep doing that. We've now got a nice hemisphere on this end of the job. The next thing I'm going to do is take the tool over and start cutting on this side. Now, because the hemisphere comes right down to the centre, we won't be moving the saddle of the lathe any further this way. So where that surface is where the surface of the ball is going to be. So the next thing I'm going to do is cut on this side to try and get this side of the ball going. We've now turned the back of this ball as far as we can go with this particular tool. Now before we can finish off the ball, what I'm going to have to do is remove some of the material from the rear of the knob around here. Once that's removed, then we'll be able to come back, reset up this tool and then finish off the ball all the way around. I remove the spherical turning tool from the tool post and then replace it with my normal 10mm diameter round nose tool. We need to plunge our ball nose cutter into the job at the right spot. Now the right spot is where this edge of that ball nose cutter is 4mm in from the bottom of the job, which is just there. So we need to move this tool exactly 4mm from the edge of the job. Now the way that we can do that is I'm turning the compound slide now, and I'm turning it clockwise. And now I'm coming anti-clockwise and I'm bringing the dial around so the 0 is at the mark, just there. Now at that point, as long as we move the compound slide in that direction, we don't have to worry about any backlash. Now I can still move the tool using the saddle here. So what I need to do is put my steel rule against the edge of the tool like this, put it very close to the job and I can see where it is, and now when that steel rule comes level with the end of the job, which is there, I now know that that part of the tool is level with the bottom of the job. We've taken out the backlash in the compound slide if I move in that direction, so I will move in that direction 4mm. And that's 1, 2, 3, and 4 just there. Right, we are now in a position where the edge of the tool is 4mm in from the edge of the job. So now we can plunge straight into the job. We now have to set up the cross slide. That's what moves the tool in this direction into and away from the job. Now I'm going to bring the tool in so it just touches the surface of the job. Normally I would do this with the motor running, but it makes a lot of noise. I'm just doing this by eye, and it's just touching the job there. And now I can set the gauge on the handle to 0, so I know the 0 point now where this tool just touches the surface. We need to advance that tool into the job 5mm. We've reached our 5mm in depth, which is good. I'm going to bring the tool out now so it clears the side of the tool, and then using the cross slide, the compound slide, move the tool in this direction 5mm. 1, 2, 3, 4, and 5mm is just there. And now I'm going to plunge back in again. I know where the 0 is on the scale for the cross slide, which is coming up just there, and we've just started to cut. Right, so we'll continue in. I'll probably go in about 4mm and see what it looks like. That's 4mm. I think I'll carry on to 5. There is now a ridge in the centre of this land. We plunged in 5mm on that first ridge there, and then we plunged in another 5mm, so there's a high portion between them. Now what I'm going to do is turn the machine on and then use a compound slide to cut that piece out in the centre. Now I won't know exactly where this wall is until I get there, because as I rotate the cross slide knob, we're going to hit the backlash. So we get through the backlash and then take off this piece in the center, keep going until the tool just kisses this surface here. So we now have a flat piece of stem between the ball end of our handle and the base end of the handle. The next thing we need to do is set up the ball turning tool again on this ball, and then we're going to take out the little lump that's left here. So take the radius of the ball right the way around until it reaches the stem that we've just machined there. With the spherical turning tool now back in the lathe, we've got to set it up again. This is quite easily done. The type of tool post I have, it retains the tool height, so I don't have to worry about the up and down movement, but I do have to worry about going in this direction here. So we move the tool in using the cross slide, and now using the compound slide bring it to the front of the job, and we need to line that cutting edge up with the center of the job. So look at the turning marks on the job and make sure that the tool is bang in line, which it is just there. Now if you haven't got the type of tool which retains the cutting height, then we will have to go up and down like this, adjusting the height until you get the same gap, or it touches each side of the job. Once it touches each side of the job and you're in line with the center here, then the tool is set up once again. With the tool set up, we turn the spindle on and then start cutting the rear of the ball here and get that blending in with the post that we've machined just here. Now if you remember, when I first machined the ball, I didn't cut it right down to size, and there's this white line here is the outside surface of the job, and that's there because the ball isn't small enough yet in diameter. Now I did that on purpose because now I've got the tool set up again, I can start adjusting the diameter that this tool cuts, and then I'll get rid of that and then make the total ball. Now the way that I adjust that is by loosening off the lock just here and then turning this knob clockwise, which will take the tool in just a little bit and will reduce the radius that the tool is cutting. We are getting very close now to the diameter that we want. There's just a little bit of wetness there, so I'm going to take in the tool just a little bit further and see if I can get rid of that altogether. That's the last of the machining. The last thing we have to do is to polish up the surface. Our ball is nice and shiny, and because of that gives us another problem. We've got to unscrew this from the mandrel. Now all those turning forces have screwed it on and it's on quite tight, so how can we grip it enough to then unscrew it from the mandrel? Well, here we have some tape, If I fold it in half, unsticky side together like this, put it on our ball and wrap it around like that. So we have now a sticky surface going onto the ball, a sticky surface on us. If I now grip that, I can now unscrew it just like that, and the surface is not damaged at all. Have you enjoyed today's video? If you have, can you go and press the thumbs up button? It doesn't cost you a penny and it's really good for the channel. Anyway, let's get back to those ball handles. And here is our finished ball handle. The Hemingway spherical turning tool has cut a very nice sphere on the top of the handle. We've got a parallel shaft going down to a flared bottom, and then the boss that fits into the job and holds this in the centre of where it's got to go. The other thing is, ta-da! I have two of them, and they're both exactly the same. And with that, there's only one thing to say. Balls! Ball handles anyway. Could you do something like this? Of course you can. And with that, this video is at an end. Take care everybody. I'll see you next time.